So just a quick review here for acids and bases and a little bit of saturated information, saturated versus unsaturated. So for acids and bases, when you name them, acids there's two kinds. So there's the kind with oxygen, without oxygen. So we have a couple examples here. So HCl, there is no oxygen. That's when you use hydro. So hydrochloric. So put hydro in front and the ending gets turned into IC, hydrochloric acid. There's no polyatomic ion kind of hiding in there. HF, again, there's no polyatomic ion hiding in there, no oxygens, so that is hydrofluoric acid. If there is an oxygen, like in H2SO4, you look for the polyatomic ion. So the polyatomic ion that would be the root there, kind of, is SO4 2-, that's sulfate. So sulfate would be, 8's go to X, ites go to S's. So 8 would go to X, sulfic acid, but that sounds weird, so we say sulfuric acid. That's sulfuric acid. No hydro for those. Not too complicated on namings. I'm not going to give you anything that's too crazy there. Something that you've seen before as far as naming goes. Now for bases, it's actually even easier. So bases, you just need to name, first of all, you know it's a base because you see the OH in it. You see the hydroxide at the end. Acids, you see hydrogens at the beginning because that's what acids do, is they donate H pluses. So there has to be H pluses for them to give off, and they're always at the beginning. For bases, NaOH, that is a base because of the OH at the end, and so you just name the cation, sodium, you name the anion, hydroxide, sodium hydroxide. MgOH2, there's actually two hydroxides that could come off for that, but still just same naming, magnesium hydroxide, nothing fancy for naming. The only one that would not follow those rules that I would give you, I expect you maybe to know the name of, is NH3, and that's ammonia. So NH3 is that weak base ammonia. It doesn't have OHs in it, but when you put it in water, it increases the concentration of hydroxide because it reacts with water to make the ammonium ion and a hydroxide ion. That'd be the only one that you would need to know the name of, maybe. And you should know that is a base. NH3 is a base. As far as saturated and unsaturated goes, if you have a solubility that is 30 grams per 100 grams of water, that would be given information. And so what that would be telling you is if I had 100 grams of water, I could put 30 grams of the solute in and it would dissolve. So if I put in less than that, if I have 100 grams of water and I put in 15 grams, that would be an unsaturated solution because 100 grams of water could hold 30, but I just put in 15, unsaturated. If I put in 35 grams in 100 grams of water, that would be saturated because it could only hold 30. I put in more than that. There would actually be 5 grams laying on the bottom. If, however, I didn't have 100 grams of water, instead I had 15 grams of solute that I put in 20 grams of water, I need to set up the proportion over here. So I would need to say that I have 15 grams in 20 grams. How much would that correspond to if I did have 100 grams? You know, how would that scale up if I had 100 grams? Fraction equal to a fraction, so you cross multiply and you'd get 75 grams. So that would be, so having 15 grams of solute and 20 grams of water would be just the same as having 75 grams in 100 grams of water. Well, 75 grams in 100 grams of water is saturated, it's full, couldn't hold anywhere near that much, right? 100 grams of water could only hold 30 grams. I put in way more than that. So having 15 grams of solute and 20 grams would be equivalent to that. It would be it'd be the same as trying to do that. So you would not be able to dissolve all 15 grams of solute if I just had 20 grams of water, so that would be saturated. The basic rule is if it's unsaturated, that amount of solvent could hold more. It could dissolve more. If it's saturated, it's full. It can't hold any more. And so anything else that you put in would lay on the bottom. Hope that helps. Good luck.